Welcome back. In this video, we're going to continue to talk about sampling distributions. If you didn't watch the first two videos on sampling distributions, or if you watched them and you're not sure if you remember the content, I would watch those first before you watch this video because we're going to pick up right where we left off. In this video, we're going to learn a new idea called standard error, which is the standard deviation of a sampling distribution. But before we talk about the idea of a standard error, let's quickly review the idea of a sampling distribution. In last week's video, we learned that a sampling distribution is a distribution of possible samples. We learned that in a random sampling situation, there are different possible samples that might be selected, and the possible samples have a distribution called the sampling distribution. And we learned that one of the possible samples will end up becoming the actual sample. So let's look at this situation right here. In this situation, two people are being randomly selected from this population of 4 people. Their 2 ages are being recorded, and the mean of the 2 people is being calculated. The person who is selecting the sample is going to record the 2 ages, and then add the 2 ages and divide by 2 to get the mean of the 2 people. And in this situation, the number that the sample mean comes out to depends on which 2 people are actually selected. And we have 6 possible samples. If person 1 and 2 are selected, that'll be two 20-year-olds, and the mean will be 20 because 40 divided by 2 is 20. If person 1 and 3 are selected, that'll be two 20-year-olds, and the mean will be 20 because, well, 40 divided by 2 is 20. So in this situation, the population members are all the same age. There's no dispersion in the population, which means that no matter which 2 people are selected, it's going to be two 20-year-olds, and the mean will definitely be 20. So no matter which 2 people are selected in this situation, the sample mean has to come out to 20. There's no other possibility. That's why all of the possible samples are stacked above 20. This is telling you that no matter which 2 people are selected, the mean will be 20, because every combination of 2 people has a mean of 20. In the first video on sampling distributions, I said that you can think of a sampling distribution as being like a spinner that spins around randomly, and where it lands is the actual sample. So here, we're basically spinning a spinner, and it's going to land on one of these boxes, and that's going to be the actual sample. And no matter which box it lands on, it's going to be two 20-year-olds with a mean of 20. So let's talk about why this matters. Um, now we're going to start to get into the idea of a standard error in just a couple of minutes. But first, we need to know these two things right here: the mean of the population and the standard deviation of the population. So the mean of these 4 people would be the total of their 4 ages divided by 4. If you add these 4 ages, they add up to 80, and 80 divided by 4 would be 20. So the population mean is 20. I'll put that right here. And if we wanted to calculate the standard deviation of the population, we would have to just follow the formula for population standard deviation. We would subtract each person's age by the mean, we would square the answers, then we would add the answers, we would add the squared answers, then we would divide the total by 4, not 3, because it's a population. And then we would get the square root, and we would get the standard deviation. But we don't have to do all of that work but in this situation, because I already know that the standard deviation of this population is 0. Because if the population members are all the same, the standard deviation has to be 0. Remember, the standard deviation measures the dispersion of the values. So if the values are all equal and they have no dispersion, the standard deviation has to be 0. So I'll put that right here. So like I said, the population mean is 20, and the population standard deviation is 0. These are just the symbols for population mean and population standard deviation. Now let's move over here and see if we can calculate these two answers. First, I need to explain what these symbols are. This is mu x bar, which is just the mean of the sampling distribution. This sampling distribution is really just showing six sample means because each box has its own sample mean. The sample means are 20, 20, 20, 20, 20, and 20. And mu x bar is just the mean of those six 20s. It's the mean of this diagram. And it's called mu x bar because it's the mean of the sample means. Remember x bar is sample mean from the video I made on symbols? And so this is really, you can think of this sampling distribution as being a population um, of possible samples, and each one has its own sample mean. So it's kind of like the mean of the population of sample means, if you want to think about it that way. I'm just trying to explain where this notation is coming from. But to get this mean of the sampling distribution, we just have to add the numbers in the sampling distribution and divide. So 20 plus 20 plus 20, that's three of them, plus 20 plus 20 plus 20 again, that's all six of them. Well, they should add up to let's see, they should add up to 120. So let me try it again. I made a mistake somewhere. Right, and then divided by 6 because there's 6 of them. So yeah, the mean of the sampling distribution is 20. So I'll put that right here. And remember, when I said that this is really just showing 6 sample means, which are all 20. So it's really just 6 20s right here. And the mean of that list is what we just calculated, and it's 20. So there we go again. Let's now try to calculate this. This is the standard deviation of the sampling distribution. And it's called the standard error because I said earlier that the standard deviation of the sampling distribution is the standard error. And that's what we're going to try to get right now. So there's actually a formula to calculate the standard error. And I haven't shown you that formula yet, but we actually don't have to have the formula to get the standard error of this sampling distribution because if all of the possible samples um, have the same sample mean, if they're all stacked in one column like this, and they're all stacked above the same number, then the standard error is 0. Because if the sampling distribution has no spread to it, if it has no dispersion, then it has a standard error of 0, just like the population. So now let's quickly recap what we just talked about. So we have a population that's being sampled of 4 people, and it has a mean and standard deviation. The mean is 20, the standard deviation is 0. In this situation, 2 people are being selected from this population randomly, and there are 6 possible samples, and each possible sample has its own sample mean. The 6 possible samples have a sampling distribution, and that sampling distribution has a mean and standard deviation of its own. The mean of the sampling distribution is pretty straightforward. We found it by adding and dividing by 6, and it's 20. The standard deviation of the sampling distribution is called the standard error. That's the technical word for it. And I told you that it's 0 because the sampling distribution has no spread to it. So it has a standard deviation of 0. So now let's move on to this next situation. So in situation 2, it's another random sampling situation. And once again, we have a population with a mean and standard deviation, and we have a sampling distribution with a mean and a standard error. So population has a mean and standard deviation, and sampling distribution has a mean and a standard error. And let's try to see if we can calculate these. Well, to get the mean of the population, we would just add the four ages and divide by 4, and it would come out to 20. To get the population standard deviation, we would just have to follow the formula that I already taught you earlier in this semester, and it would come out to 1.41. If you wanted to check my answer, you could do the work yourself and check it out on your own, but you should end up getting 1.41. Now let's go over here and try to get the mean and standard error of the sampling distribution. To get the mean of the sampling distribution, you would just do the same steps we did last time. Just add the 6 numbers and divide by 6. So it's going to be 2 19s, 2 20s, and 2 21s all added up. And when you divide that by 6, you'll end up getting 20. So that's the mean of the sampling distribution. Now let's move on to the standard error right here. In this situation, we can't get the standard error just by looking at the diagram like we did over here. We have to have a formula to get the standard error, and I haven't taught it to you yet. Um, so I'm not actually going to calculate the standard error right now because um, the purpose of this video is really just to help you understand the idea of the standard error, not the calculations, because the calculations will be coming later. Here I just want to give you create some visuals for you so you just get the idea down. So right now I'm just going to put a question mark right here. So I'm just basically saying that we don't know what the standard error is. It's unknown. But just so you know what's coming, I'm going to tell you a little bit about how it's calculated. So the formula to get the standard error in this situation would require three different things. You would need the population standard deviation, you would need the sample size, which is 2, and you would need the population size, which is 4. So you take the population standard deviation, the sample size of 2, and the population size of 4 and plug them into a formula, and you would get this standard error. And that standard error is the standard deviation of this diagram, the sampling distribution, and it measures how spread out the sampling distribution is. So yeah, that's the whole idea. Now let's move on to situation 3. In this situation, the population mean and population standard deviation in this situation, the population mean and population standard deviation are the same as what they were in situation 2 because it's the same population. Situation 3 has the same 4 people that situation 2 has. So these two numbers aren't changing, but one of these numbers might change. So let's try to find out what they are. To get the mean of the sampling distribution, we just add the 4 sample means and divide by 4, and that's the answer right there. So these numbers are actually 19.3, 20, 20, and 20.7. That's because the mean of these 3 people is 19.3. The mean of these 3 people is 20, the same for these 3 people, and the mean of these 3 people is 20.7. You could check that if you want to double check my work, but I'm just telling you that that's what they are. So if you add those 4 numbers and divide by 4, you get the mean of the means, which is 20. And remember that it has to be the same number as the population. So the mean of when a sample mean is being calculated, the mean of the sampling distribution equals the mean of the population. That's something that you saw in one of our last activities from before spring break. So I could just put 20 right here. And to get the standard error, we would need to use a formula. And I said that we're not going to be calculating these standard errors in this video, so I'll just put another question mark. So even though I don't know what these 2 standard errors equal in situation 2 and situation 3, I do know one thing. I know that this standard error is the largest standard error for all 3 situations. That's because in situation 2, the sampling distribution is the most spread out. It has the most dispersion to it because it goes all the way from 19 to 21. And In this situation, it's closer together, and in this situation, it's even closer together because it's all at 20. And so yeah, this is the largest standard error. This one is definitely the smallest standard error because it's 0, and this one is somewhere in between. So there's a couple more things that I want you to understand before I close this video. So I want you to be able to see what the standard error is affected by. So one thing it's affected by is the amount of dispersion in the population. When the population has less dispersion or less spread, the standard error will be smaller. So if the population has no dispersion, then the standard error is 0. And when the dispersion of the population members goes up, the standard error will get bigger. That's why the standard error got bigger when you go from situation 1 to situation 2. It's because the population got more spread out. The second thing that the standard error is affected by is the sample size. So when you go from situation 2 to situation 3, um, the sample size is going up. I'm sorry, this shouldn't have been a 2. This should have actually been a 3 right there because we're selecting a sample of 3 people. So the sample size is going up from 2 to 3. So 3 people are being selected instead of just 2. And with a bigger sample size, the standard error goes down. So overall, the standard error is affected by the amount of dispersion in the population and the sample size. Um, when the population has more dispersion, the standard error goes down. Um, and when the sample size goes up, the standard error goes down. One other thing I want you to realize is that when the standard error is small, um, the sample mean is more likely to be close to the population mean. Because if the standard error is 0, then the sample mean has to come out to the population mean. You can see in this situation that the sample mean has to come out to the population mean of 20. And if the standard error is bigger, it means that the sample mean is likely to be further out from the population mean. You can see here how the sample mean could come out to anything between 19 and 21. And yeah, so a big standard error means that the sample mean is likely to be further out from the population mean, and a small standard error means that the sample mean is likely to be closer to the population mean.